everyone. My name is Sergio, and today we'll be going over trigonometry, specifically pre-calculus, and the application of sum and difference formulas. We will now solve this problem, and that is solve the exact value of the tangent of 15 degrees. So do not express your answer as a decimal. Make sure that it's in fractional and radical form if you have to. So spend some time solving this problem, and when you come back, we will solve it together. Okay, so the idea here is to use these three angles, or sometimes even the 0 degree or 90 degree if you have to, but you have to use these angles such that you get a result that either sums up or subtracts to 15 degrees. So what do you think will be the likely values of the angles that'll either sum up or subtract to 15 degrees? Well, just by looking at the unit circle, if I take the difference between 45 degrees and 30 degrees, I end up with 15 degrees. So that's the likely expression that you will be substituting in the argument, which is the number inside the parentheses. So we will go ahead and re-express 15 degrees as 45 degrees minus 30 degrees. Okay? And now it fits the form of our general formula. So if you look at this value, it's alpha, and this value is beta. So now we can substitute these values into our equation up here. So it says that the tangent of 45 degrees minus 15 degrees, or 30 degrees, that's going to be equal to, well, the tangent of alpha. So we said earlier that alpha was 45 degrees. So we'll substitute in a 45 degree angle there. And then the signs, since it's minus, we will be using the same sign here. So minus the tangent of beta, which is 30 degrees here because it's the second angle. Okay? And then we take the ratio of that with 1. Now here, it's very important. If this is a minus sign, we will use a plus sign because it's the opposite of the sign is opposite of that in the argument. And then we take the tangent of 45 degrees, and lastly, the tangent of 30 degrees. All right, so that is the expression. Now we have to actually evaluate these functions. Recall that the tangent function of an angle, theta, measured from above the horizontal counterclockwise, is the y value over the x value. And these are the x, y values of any point along this unit circle. So the tangent of 45 degrees, we'll go ahead and do this up here for clarity, is going to be equal to the square root of 2 divided by 2 over the square root of 2 divided by 2, because this is the y value and this is the x value at 45 degrees. And this ratio will come out to be equal to, you guessed it, 1. All right. Now on the same note, I will do that same process, but instead of using 45 degrees, I will use 30 degrees. So that gives us this point along the unit circle. So the y value there is 1/2, while the x value is square root of 3 divided by 2. Whenever you have a fraction on the denominator, you multiply the numerator. So I'm going to write the numerator with a set of parentheses so I can identify the differences, right? Numerator and denominator. You multiply the numerator by the reciprocal of the denominator. The reciprocal of square root of 3 over 2 is just 2 over square root of 3. So therefore, this becomes equal to, you leave the numerator the same, 1/2, but you multiply that by the reciprocal of square root of 3 over 2, which is 2 over square root of 3. And now, 2 divided by 2 is simply 1. So the tan of 30 degrees is simply 1 over the square root of 3. And now we have to rationalize the denominator. The way you rationalize the denominator is we want to get a real number on the bottom. That's not a rational function. So you multiply by that rational function to both the top and the bottom of the fraction. Because whenever you have two square roots being multiplied with the same base, the square roots cancel out to 1. So therefore, the tan of 30 degrees is 1 times the square root of 3, which is square root of 3, and then square root of 3 times square root of 3, the squares cancel, square roots cancel, and we get the stuff on the inside, which is 3. So now we will use this value within this function. These two values we will use in this function. So now tangent of this difference was 15 degrees, so I'll just write it as 15 degrees to correspond with the original answer, is equal to tan of 45, we said that was 1, and then minus the tan of 30, which was root 3 divided by 3. Now put a set of parentheses there so I could distinguish between my numerator and my denominator. And I will have on the denominator 1 plus parentheses 1 times square root of 3 over 3. Okay, so now I'm getting closer to my form. So I have the tangent of 15 degrees is equal to, here I will find the common denominator. So the common denominator, you have to multiply 1 over 1 by 3 over 3, because that'll simplify to 1 again, but I am just finding the common denominator. And then I will divide by, again, the same process. 1 times the square root of 3 over 3 is just square root of 3 over 3. So I'll have the same expression down here, except it will be a positive sign. So here we have 3 over 3 minus root 3 over 3. The goal was to find the common denominator so that we can combine the fraction, the two fractions into one fraction. So we are just using a lot of algebra here, so make sure that you are well acquainted with the arithmetic. And if you have any trouble, again, you can watch our previous videos that we have on the channel, or you can come visit us at the QLab. So here, this will be 3 minus square root of 3, all over the same denominator, 3. And again, I always employ these set of parentheses so that I can differentiate between my numerator and my denominator. Okay, so I will have the same expression here on the bottom, except with a positive sign. And again, we apply the same rule that we did earlier, where we have a fraction on the denominator, so we multiply by the numerator by the reciprocal of the denominator. So I have 3 minus root 3 over 3. Multiply the reciprocal of this expression is simply 3 over 3 plus square root of 3. And now again, simplifies because these two cancel to 1, and I am left with the tangent of 15 degrees is equal to 3 minus square root of 3 over 3 plus square root of 3. Okay? Now, this step is very important. Again, we don't like radical expressions on the denominator. So one thing we have to do is we have to cancel out that square root on the bottom. One way of doing so when you have this addition on the denominator is by multiplying by the conjugate of the denominator. The conjugate just means that the radical function will be flipping signs when we multiply this value by the conjugate of it. So let me just show you. It's a little difficult to explain, but it'll be 3. Since this is positive, the conjugate of this will be minus square root of 3. And then if you do that to the denominator to keep the consistency of the equation, you must do it to the numerator. Because again, we're not changing the numerical value of the expression. All we're doing is rewriting it so that we don't have the square root on the denominator. So then now tan of 15 degrees is equal to 3 times 3 is 9, minus 2 times 3, which is 6, square root of 3, plus 3. All of this over 9, And then the middle terms cancel out the radical terms, and that was our primary goal. And then I have minus 3. Again, this is equal to 9 plus 3, that gives us 12, minus 6 square root of 3, all over 9 minus 3, which ends up being 6. And again, by the common denominator, I can say that the tan of 15 degrees is equal to 12 divided by 6 minus 6 divided by 6, and then the square root of 3 is tagged along there. 12 divided by 6 is equal to 2, and then 6 over 6 cancels, and we're just left with the square root of 3. So after all of the math, the algebra, the arithmetic we have applied, we have reduced our answer to 2 minus square root of 3. The last thing to do is to box this answer, because this answer is the answer to this problem. We have now found the exact form of the tangent of 15 degrees using the sum and difference formulas. And if you have any further questions or concerns, please feel free to leave a comment on the comment section below. And don't forget to subscribe to our YouTube channel, along with our Facebook, Twitter, and Instagram media pages. The links to those will be in the comment description. And again, if you have any further questions, feel free to visit us at the Q Lab as well. We are open Monday through Thursday from 10 all the way up to 8 p.m. and Fridays from 10 to 4 p.m. We are also open on Sundays from 12 to 7. Thank you, and you have a great day.